we'll see if this works. 9. So I got a new mic. Hopefully I can record now. My old one broke a long time ago, but okay. So the first thing in Unit 9, I chose these questions. A few of y'all had emailed me about questions y'all had, but I also included, basically everything that's going to be in your post-homework or the test itself. So the first thing is finding the intercepts or the zeros from the graph. I thought we did this already, but that's okay. As long as you know what an intercept is or what a zero is, this should be fairly easy. So what is an x-intercept? Yeah, it's where it touches the x-axis. So this one looks like it's crossing at, I can't even tell.
7.
Yeah, so it looks like -6. So the x-intercept we would write as an ordered pair, and the 0 is just the number. There's 2 on here, so we got one crossing at 7. So 7, 0, and then the 0 that goes with that, just the 7. So these should be nice. I'm pretty sure you have one of these on the test, so it should be basically free credit. Yes?
Okay, so on the little homework thing, if you didn't put the comma in the middle of it, it gave wrong answer. So, like, do you have to put the comma in the middle, like, between the parentheses?
Oh, like that?
Yeah.
Yeah.
Okay.
Yeah, and if something like that happens on like a test or something, just let me know. It's a homework, Suck it up. Just redo the problem. All right, next one looks like it crosses at -2. And 1, 2, 3, 4, 5. Did I count that right? We'll assume I did. So the zeros are just -2 and 5. So I'm almost positive you have one of those on the test, but again, it should be real easy for y'all. Finding the x-intercepts from the equation. This is something that's on your last test. It was just worded slightly differently. Your x-intercepts and your zeros are very closely related, right? And we found zeros in the last test. Here we're finding the x-intercepts. So how do we do that? How'd you get that?
Find multiples of 21 that add up to be -10.
Yeah. So let's see. -7, -3. So that would be the factorization. And from the factorization, we can set each factor equal to 0. Solve each of those. 7 and 3. So I won't go through that whole process. I mean, if you've got the factor, you can find the 0. That's kind of like one of our key ideas for this test. So I won't go through all this every time. Next one, x squared plus 6x plus 5. What am I looking for? Yeah, they've got to multiply to give me 5 and add up to give me 6, so that's 5 and 1. Now once I've got the factors, the zeros are, yeah. Ooh, I wasn't even paying attention. This says list the x-intercepts, so be real careful. Write that as an ordered pair for each of these. So 7, 0, and 3, 0. -5, 0, -1, 0. Yeah, that's the next type. So you got to look at the directions and say, is it asking for a 0 or is it asking for the x-intercept? The intercept is the ordered pair. The 0 is just the number. So the ones like this one says find the zeros. What works here? What multiplies to give us 18 and adds to 9? Oh, yeah, that works. All right. A plus 6 and a plus 3, so the zeros are negative 6, negative 3. Okie dokie. All right, I got a bunch of emails about this. Find the vertex. We did this last time. The way we did it in class is we found the zeros, right? And then we just looked halfway in between those. See this? So we can do that. We'll do that for this first one. So the zeros, let's see, 4 and 2. Right? Those multiply, give me 8, add to 6. So the zeros are negative 4 and negative 2. And I always have to kind of look at this to see. It's not a great picture. So zeros are, dang it. Third try here. So my zeros at negative 2 and negative 4. Right in between those is what? Yeah, x equals negative 3. So that's going to be the x value of my vertex. To find the y, I would just plug x in. Negative 3 squared plus 6 times negative 3 plus 8. So that's 9 plus negative 18 plus 8. So negative 9 plus 8 is negative 1. And that gives us our vertex. We had our x that we found up here, the negative 3. And the y we got from plugging it in. Do y'all remember that from last time? Yeah, I know we did a lot. For this one, I want to show you a different method. And that's to use this formula, x equals negative b over 2a. All right, so here we've got a equal to what? 1? It's just the coefficient in front of x squared. B is negative 4. So we've got the 2 that we need. We would just plug those into this formula. Negative b is going to be a negative 4. And then 2 times a is 2 times 1. So that simplifies to 4 over 2, or just 2. Oops. So that's an alternate way. It can be a lot faster, as long as you remember the formula. That's another way to find your x. And then how do we find y? Plug it in. Yeah. So let's see. 2 squared minus 4 times 2 minus 5. 4 minus 8 minus 5. Negative 9? Okay, so then my vertex is that x I got before, the 2, and then the y I just got here. Okay. Yeah. Ooh, I really need a burp, but I don't want to do it on camera. I don't want to do it right into the mic. We'll see how long this lasts. Not very long. Good? If you don't get it, that's okay. I'm going to post the YouTube link this afternoon. Okay, determine if there's a max or min. Again, we talked about this last week, but all we're really looking for is, does it open up or down? Do y'all remember what you look at to tell? The sign? The sign in front of the x squared. So yeah, in this case, we're looking at these two things. We got this one, and over here we've got this one. So the -2 is going to go which way? That one goes down, which means it doesn't have a lowest value, it doesn't have a minimum, but it does have a max. Right? We can only go up to that vertex. Over here, the +9. Yeah, of course, that one goes the other way. That one goes up. And so that has a minimum. Again, I'm almost positive this is on your test. That should be free credit. We'll talk about that, I think, on the next page. When it comes to those matching graphs, a lot of times this is going to be really useful. This is going to eliminate a lot of choices. Just telling, just looking to see whether it goes up or down. You can use that to eliminate some choices. Hey, nice to see you. I like the hair. All right. Now, I don't know if we talked about this last time, finding the y-intercept, but this is a great tool here, just like it was when we were talking about linear equations. So just like linear equations, this comes from that constant term. That's the term at the end without a variable. So a lot of times on these matching graphs, this can be helpful. Also, you'll have problems where it just asks you, what is the y-intercept? So you kind of have to know this. And again, it just comes from that term. So how would I write that? Ah, very nice. That ordered pair. So we'd write that like 0, 8. And then over here, the y-intercept. Yeah. I don't know how I ended up with the same numbers. Well, I do, because I just took these from the homework. So, okay. Oh, so here we go. Here's the graphing stuff, and that's one of the first things I look at on these graphs is that y-intercept. Just because it's right there in front of me, I don't have to do any work to see it. So which one of these graphs does not have that intercept? Well, that one does have it, right? Doesn't it? D, okay, yeah. So this one, it crosses down here. It looks like -1. So I know it's not that. Same thing here. It looks like it crosses at -1, so I know it's not that. So easy way to wipe out a couple of choices. What else can we do? Yeah, you see you've got those other points there. It looks like they've got the x-intercepts and the vertex. I mean, you could find the vertex if you want, but for these, we give you nice simple ones with no leading coefficient. You should be able to find the x-intercepts really easily here. So the intercepts, let's see. What multiplies is going to be 15 and adds to -8? Yeah. Am I good? Yeah. So the zeros that go along with that, +3, +5. Oh, yeah. So which ones cross at 3 and 5? Let's see. And you've got a bunch of these on the homework, and again, I'm pretty sure you'll have one on the test. So same deal. I always look at that y-intercept. So which ones can this not be? This one has a y-intercept of 80. This one is also 80. It could be either of those. So now what? Y'all figure it out. Did I hear a B? I heard a D. How'd you get that? Toss the coin. Another D. How are y'all getting these?
You factor it.
Factor, okay. I'll take it. So you factor into
X minus 4, x plus 2.
does that work? Multiplies give negative 8. Adds the negative 2. Very nice. Let's see. Negative 2, good. And 4. Looks good to me. Okay. Now, the more fun problems are the ones that don't give you a graph. But, I mean, you're just going to do the same thing you just did, right? Although these oftentimes ask you to list a bunch of other information, like find the vertex, does this thing open up or down, find any intercepts, and then graph it. So that's kind of more complicated than it looks, I guess. I mean, just sketching it, we could do exactly like we've been doing. So I want to skip over the vertex for now. Does this thing go up or down? Up. Okay, so we know it's going to look something like this. Intercepts, does it have any intercepts? Y-intercept is 0, 15, yeah. We can find the x-intercepts as well. So we got, I'm going to circle all these answers. There's up, there's our y-intercept. To find the x-intercept, what, we want to factor this? This looks familiar. Yeah, I was about to say, we just did this. So we've got 5 and 3 as our zeros. As x-intercepts, we write the ordered pairs. All right, so we've got up, we've got the intercepts, we can do the vertex. Really, this is enough to graph it. But I guess we can go ahead and find the vertex. How do y'all want to do it? Which way is the easy way? Okay, so you want to find what's in the middle of these? Actually, that should be pretty easy because 3 and 5, what's right in between those? 4? So x equals 4, since that's right between 3 and 5. And then y is 4 squared minus 8 times 4 plus 15. 32. 16 minus 32 is negative 16 plus 15, negative 1. So now we've got everything they've asked for, except the graph. But we've got a lot of points we can plot here. There's 3, 0. There's 5, 0. 4, -1. In our software, that's actually enough to graph it. But we'll go ahead and graph the y-intercept as well. 1, 2, 3, 4. Just for fun. Boom. Did y'all enjoy that? Did y'all enjoy that as much as I did?
Very much so.
I mean, that's a pretty intense problem. I feel like you're going to see a couple of these on the test. Typically, when we've got something like this that sums up everything, you should definitely look for that on the tests. I'm not positive. I just looked through the test review. I haven't even looked at the test since the summer. Not what you want to hear, right? Nah. Okay. All right, in Unit 7, this is the one you only have a couple of questions from, but you still got to know how to do it, and it should be pretty easy, right? So y'all remember how to use this quotient rule to simplify?
Divide and subtract exponents.
Yeah, so the number parts you just divide, and then for the exponents you subtract. So 18 divided by 6, -3. A to the 6, a to the third, so we subtract 6 minus 3. 3. There's going to be a lot of 3's in this problem. B to the 5th, minus b squared, b to the 3rd. And then 14 minus 8, c to the 6th. Okay. (22/16). That one's kind of weird. Well, I can divide 2 out of both of them. And I get, what, 11/8? And don't forget that minus sign, which I almost forgot. X to the 8 over x to the 5th. Again with the x to the 3rd. What about these y to the 7th? Boom. So on that last test, we had some problems similar to this, and a lot of mistakes I saw were people put things on the wrong part of the fraction. So like that 8 came from the 16, which was on the bottom of the fraction. We leave that 8 on the bottom of the fraction. So don't go moving things around for no reason.
So the answer would be 2 times, right? Because you pulled a 2 out.
So I guess you could think of it this way. We had a 2 times 11, 2 times 8, and we canceled the 2.
Okay.
So there's no 2 anymore. So that would be the answer, just what we've got. I don't know why I put so many of these. I guess I did this before I checked to see how many were actually on the test. That's okay. I mean, these are pretty short. 20/8. Yeah, those are both divisible by 4. We divide them both by 4 and get 5/2. X to the 9th over x to the 3rd. And then y to the 11th over y.
1 and 10.
Okay. So those are pretty straightforward. We also have this type of problem where you've got more than one term on top. Pretty scary, right? Are you scared? Don't lie to me. I know y'all are scared. No, just kidding. Suggestions?
Divide them both by 4.
Okay, and
Subtract exponents.
yeah. And Normally when I'm doing this, I split these up. Right, so each term is going to be divided by this 4x individually. And so I get what? 4x, 8 over 4 is 2. This one looks like a bigger pain. But again, I just split this up into two fractions. Whoops. All right, let's see. 15. 12. So 12 over 4 is 3. Yeah, 5 minus 4 is 1, so 8 to the first. B squared over B, just B. Just 4, okay. Cool. Oh, wow. I don't know why I was thinking that was the end of this. I guess not. But Unit 8 is basically synthetic division all over the place. That's pretty much all we did in Unit 8, right? So use synthetic division to divide. I do remember this. Sometimes you can ignore those instructions. Like here, I've got a quadratic. I can factor a quadratic pretty easily, right? So, you know, no one's looking over your shoulder to make sure you're using synthetic division. So I'm going to ignore that for this first part. I'm just going to factor this out. And this factors into, what, 6 and 2? Yeah. X plus 6, x minus 2. And now when I divide that by x minus 2, the x minus 2's cancel, and I've just got x plus 6. So sometimes you can save a lot of time and just factor it. Now, if you really want to do synthetic division, you could. So we just write down our coefficients, 1, 4, negative 12. And then in my little box over here, what number goes here? 2. Very nice. Remember, we have to change that sign. So bring down the 1, multiply, add, multiply. So yeah, for some of these you have to do synthetic division. Well, I don't know. Could this factor? No, it's not. Weird. Thank you. Okay, so the quotient, again, we've got these new coefficients. For a polynomial that's 1 less than this, instead of x cubed, it's going to be x squared. So we've got 1x squared minus 14x plus 84. And y'all remember how you write the remainder for this? Very nice. So the idea is the remainder hasn't actually been divided by that, so we just leave it for someone else to divide. Okay. Do y'all really want me to run through all these? I mean, how comfortable are you with this? I guess really I just want you to see how these questions are set up. Yeah. As long as you can interpret this and know that you have to do synthetic division, you should be good. So they've given you a polynomial and they've given you this number here. They say use the remainder theorem to find P of C. So what are we going to do? Mm-hmm.
We don't make it into a negative, but the only time we make it to a negative is like if it's x plus
Yes. The only time you change that sign is when they actually give you a factor, like x plus 5, x minus 3. Anytime they give you a number, you just use that number with your synthetic division. So so we're looking for this value, P of C. What does that come from? They give it away. Where are we going to get P of C from? Thank you. So just do synthetic division and look at the remainder. Again, so this one I actually pulled the question from the practice test because I wanted to look over the language of this. Use synthetic division to show that x plus 2 is a factor of this. And this giant polynomial by x plus 2, the quotient is, so that would be whatever new polynomial we get. The remainder, they just want the number. I guess I should actually do this one so you can see what I'm talking about. So they actually gave us the factor x plus 2, so we do need to change that sign to a negative 2. And I get a 26. So the way we would write this answer, the quotient is these three, the 1x squared plus 2x plus 5. The remainder is that 26. And then this part, how does synthetic division show that x plus 2 is a factor? Ooh, did I screw this up somehow? Probably. That is definitely not a factor, huh? So it doesn't? Right, we got a remainder of 26 here. That tells me that this thing is not a factor. So I think I actually just had a typo here. I don't think you'll ever see this part unless it actually is right. So in our case, x plus 2